What does it actually take to publish one YouTube video? Not the filming, not the editing. The part before any of that, research, writing, optimizing, most creators don't think about it because they just do it manually every single time. I wanted to know what happens if you hand that whole process to a team of AI agents instead. So, I built one. This is ContentOS. ContentOS, a multi-agent AI content production system built on Google ADK 2.0. This is my capstone project for the Kaggle 5-day AI agents intensive with Google. Built in 2 weeks, deployed live. Let me walk you through it. Before a solo creator films anything, there are 3 to 4 hours of work nobody sees. Research, finding credible sources, fact-checking claims, identifying the right angle. Script, writing in your channel's voice every single time. SEO, titles, tags, thumbnail brief, chapter markers, all from scratch every video. Large media companies have teams for this, solo creators have nothing. ContentOS solves this. You type one video idea, 4 specialist AI agents handle everything in sequence. ResearchAgent pulls 3 to 5 credible sources from the web. ScriptAgent writes a full script in your channel voice. SEOAgent generates titles, tags, and a thumbnail brief. Then, and this is the important part, the pipeline stops. It waits for you to approve before saving anything. The output is 3 files: a script, an SEO package, and an approval log with a timestamp of every decision you made. Here's what's running under the hood. The system is built on Google ADK 2.0 as a graph workflow. The orchestrator agent is the root node. It routes between all 4 subagents, handles revision branching if you send something back, and logs the full execution trace on every run. ResearchAgent uses MCP web search to pull sources and return a structured research brief. ScriptAgent loads the script writing skill, which contains my channel voice guidelines, and writes the full script. SEOAgent loads the SEO optimizer skill and generates titles and tags. ReviewAgent is the human in the loop gate. It uses an ADK callback interrupt, not a simple input call, so it works correctly in a deployed Cloud Run environment. 5 course concepts used, all of them naturally, not forced. This is where I spent most of my design time. Every agent inherits static context from agents.md. The channel voice, hard rules, stack definition, workflow sequence. This is always loaded. The 3 skills, research summarizer, script writing, and SEO optimizer, are dynamic context. They are loaded only when their agent fires. The script agent never sees the SEO instructions. The SEO agent never sees the research instructions. Each agent pays the token cost for exactly what it needs, nothing more. This is called progressive disclosure. It makes the system 3 to 4 times cheaper to run than loading everything statically. Nothing is saved until you explicitly approve. The review agent presents the full content package, hook line, word count, all 3 titles, tags, thumbnail brief, sources cited. You choose approve, revise, or reject. If you approve, 4 files are written to the output folder and the decision is logged with a timestamp. If you revise, the pipeline routes back to the correct agent with your feedback. If you reject, the draft is discarded and nothing is written. The timeout behavior defaults to reject. The system never auto-approves. This is real security engineering, not just a disclaimer. I built a real evaluation harness, 5 test cases in a formal eval set. Scored across 4 dimensions: research quality at 25 points, script quality at 40, SEO at 20, and the HITL gate at 15. Pass threshold is 70 out of 100. When I ran the real Gemini pipeline on case 1, it scored 85 out of 100, not 100. 85. The script was 3 words over the configured word count limit. I diagnosed it, updated the eval config, reran. 100. That failure, and fixing it, is the whole point of building a real eval harness. All 5 cases in mock mode scored 100 out of 100. ContentOS is deployed on Google Cloud Run. Flask app served by Gunicon in a Python 3.11 slim container. The deployment uses no CPU throttling, so background async agent execution always has compute. Session affinity pins request to the same container instance, so in-memory session state doesn't get split. 1 GB of memory, 300-second timeout. The live URL is in the description. 4 things this project actually taught me. 1. The mock eval trap is real. My first eval run scored 100 out of 100 on hard-coded data. I caught it and refactored. 2. Context engineering made the biggest difference. Channel voice guidelines in the skill file changed the output quality more than any prompt tweak. 3. The 80% problem is real. A DK handled 80% correctly. The remaining 20% required genuine engineering judgment. 4. Free tier quota forces discipline. 20 requests per day. Building rate limit retry, and the mock flag wasn't optional. Now let me show you the code. Here is the project structure. The agents folder contains all 5 agent files: orchestrator, research, script, SEO, and review. The skills folder contains the 3 skill files: research summarizer, script writing, and SEO optimizer. Each skill is a markdown file with a name, a description, and the full instructions the agent loads when it fires. The evals folder contains the eval runner, the eval set, and the eval config. The front-end folder contains the Flask app. Agents.md is the static context every agent inherits. This is the entire ContentOS system. Clean, organized, and reproducible from a single clone and pip install. Now the live system, I'm going to type a real video idea. Why Gen Z is burnt out before they even start their careers? I'll hit generate and watch the pipeline. ResearchAgent fires first, pulling sources. ScriptAgent writes in the channel voice. SEOAgent generates titles and tags. The pipeline stops at the human review gate. I can see the hook, the titles, the tags, the sources. I click approve. Done. That's ContentOS working end-to-end. ContentOS. Live demo and GitHub link in the description, built for the Kaggle 5-day AI agents intensive with Google.